So here we are, chapter 10. We're going to do the conic sections. Remember, there's 4 conic sections. There's the circle, the ellipse, parabola, and the hyperbola. We're going to start tonight's discussion with circle and ellipse. Those are our first 2 sections. Now we all know what a circle is. It's a set of points that are the same distance from a fixed point. That's the formal definition of the circle. And as we know it, there's a center, and then there's all the points that are around it, the same distance, we call a radius. So if we wanted to look at maybe the equation of a circle in standard form, the equation looks like this. X minus h squared plus y minus k squared equals r squared. The h and the k are our center, the r is the radius. For example, if I gave it to you standard form like that, you can see what our center would be and what our radius would be. Notice the plus 3 would give you a negative value for the y value. You can write the circle in general form, x squared plus y squared plus dx plus zy plus f equals 0. And if you do a little algebra, you can turn it into the more useful standard form. And that's what I'd like to focus on next. In order to do that, we're going to have to remember how to complete the square, completing the square. And remember, the idea is to get your x squared coefficient equal to 1, divide by the middle term by 2 and square it, and then add that new number to both sides. Those are the 3 steps to completing the square. An example is shown below. If we want to turn the left side into a perfect square, we follow the 3 steps above. Now we got a perfect square on the left-hand side. Alright, now how do we use this? Well, let's say that we have a circle equation in general form, and I'd like to turn it into standard form. Put your x values together, put your y values together, and move the constant to the other side. Now notice I leave a little space, and those are the magic numbers, if you will. It's going to be half of 8 and square it, which is 16. Half of 6, which is 3, and square it is 9. So I want to add 16 and 9 to both sides. This thing is now a perfect square if you factor it. The second thing is a perfect square, and the right side equals 4. It's in standard form. My center is at 4, 3. My radius is 2. How can we apply this to the ellipse? So the ellipse is a special, the circle is a special case of the ellipse. You can have horizontal or vertical. Those are horrible drawn ellipses, but you get the idea. If we look at an ellipse, I'd like to point out a few major points. First, those 2 special spots are called the foci. The long axis is called the major axis. The shorter axis is called the minor axis. You got it. The endpoints that are special are called vertices. Each one is a vertex. So, standard form of an ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. The center is still hk. Here's where things get interesting. A is the distance from the center along the major axis to the vertice. It's the longer one. Any guesses what B is? Yeah, it's the center to the vertice on the minor axis. Of course, both sides are like that. Now, the one thing we don't know is the distance to the focus. We call that C. And in an ellipse, C squared equals A squared minus B squared. So if I give you a ellipse in the standard form, you can see the center is 2, negative 2. A in this case is equal to 2, B is equal to 1. So the length from the center to the vertice, and C is root 3, and you can see how I figured that out. So that distance is 2, that distance is 1, and that distance between there and there is root 3. If the center is 2, negative 2, you can figure out where all the vertices are. And you can check my math. I think I got them right, but let me know if I didn't. Alright, on to bigger and better things. the general form of the ellipse. ax squared plus by squared plus dx plus ey plus f equals 0. We'll do more with this later, but you should know that we can turn this into standard form if we need it. If the x value is over a squared, it's a horizontal. If the y value is over the a squared, it's a vertical. How do you know the difference? A squared is always, always, always the bigger of the two. A is always bigger than b. So here's an example. Try to stay with me. We're going to put the two x values together, the 4x squared and the 8x. We're going to put the y values together, and we're going to move 4 to the other side. Rewriting it like that. Now I want to factor out the 4. I want to factor out the 9. I'm going to leave spaces for those magic numbers. Now one happens to be 1, but it's really 4 times 1, so we add 4. The other one is 9 times 4, I add 36. Completing the square, I've now turned it into perfect squares. Divide through by 36. 4 over 36 is the same as 1 over 9. 9 over 36 is 1 over 4, and you get 1 on the right side. We'll talk about that tomorrow. Have a good night.